it's not just the astigmatic eye that has two focal lines. The spherocylindrical lens also has two focal lines, and we're used to seeing them on the lensometer. First, we bring in focus the first focal line. We call it the skinny lines, the sphere power. Then we bring into focus the second focal line. Those are the thick lines in the lensometer. And when we're doing the lensometer, we take the diopter power of the first focal line and record that as our sphere power. Then we look at the diopter power for the second focal line, but we don't record it like that. What we record is this. See how that works? If not, I'm going to show how it corrects the eye, so it'll be a little bit easier to understand when you see what it does to the astigmatic eye. And then if you look at those purple lines with the arrows, that tells you that the steeper curve is horizontal at the 180, and the flatter curve is vertical at the 90. So it's the flatter vertical one that's our axis. So the axis is 90 in this case. Okay, how does the lens correct the eye? Okay, we know that this lens corrects astigmatism, and we also know that it corrects mixed astigmatism. How do we know that? By the power cross, the plus and minus on that power cross. Okay, we also know from the power cross that in order to move those solid red lines, the focal line that they form, in order to move that onto the retina, because right now it's in front of the retina, in order to move that onto the retina and focus it into a point, we need a -2 lens. We also know that those dashed green lines that fall to a focal line behind the retina, in order to move that onto the retina, we need a +3 lens. So why does our prescription read cylinder of +5? Well, our -2 diopters did move our solid red lined focal line back onto the retina, but it didn't just move that focal line back, it moved both focal lines back. So now our dashed green ones that only needed a +3 correction have to compensate for being moved back -2. So they have to add another +2 to bring it back where it was, and then the +3 to correct it onto the retina. Okay, this is our astigmatic eye with mixed astigmatism, the conoid of Sturm, the circle of least confusion. The circle of least confusion got brought back with the -2, and it was collapsed with the +5. Spherical equivalent. The spherical equivalent would be for people with just small amounts of astigmatism. In a case, maybe they want to purchase contact lenses, and instead of getting toric lenses, which are more expensive and a little more difficult to fit, maybe just spherical lenses would be a good option for them. I'm going to use the same prescription that we've been using throughout the video. And what you would do to calculate the spherical equivalent is take your sphere power and half your cylinder power. Add those together, and then you come out with the spherical equivalent. And we come out with a half a diopter, a +0.5, and if we look at where our circle of least confusion is, the +0.5 brings it here, right onto the retina. And that's the whole point of the spherical equivalent, to move the circle of least confusion onto the retina. It's not the same thing as finding the perfect refraction, but it's a close second in some cases. Now, in this patient, this would not work really well. +5 is a lot of astigmatism. This patient, if you try to use the spherical equivalent, will not see clearly. It will eliminate the distortion, but there'll be a lot of blur. And even a patient with a small degree of astigmatism will be sacrificing a little something by going with the spherical equivalent, but sometimes it's worth it.